Hello, student. This is Mr. Teo again. Last week we completed chapter 3 for the ADC, DAC, and signal conditioning. This week we are going to begin with chapter 4, and we will start it off with block diagram manipulation. So without further ado, let me turn on the slides for chapter 4, beginning of chapter 4. Now let me share the screen. Share the sound first, and I will hide the control panel, and it will start.
After completing Chapter 2, which is the measurement and control element, we went to Chapter 3, of which case we touches on signal conditioning, ADC and DAC. Recall in signal conditioning we mention about noise filtering using filters, amplification if signal is weak. Then we moved on to ADC where we discussed about sampling, Nyquist theorem, aliasing and quantization. At the end of Chapter 3 we also discuss of DAC and the method of implementation. This chapter we are going to discuss on the process plant itself. In practice, a process plant can never be a simple one-block system. It is a makeup of many complex subsystems. Hence, the first technique introduced in Chapter 4 was to use the block diagram manipulation to simplify a complex subsystem transfer function into one single block transfer function that is manageable. Following that we will discuss first order and second order system and its characteristic. We will go further by introducing students to steady states response and steady states error. We will also introduce student to analyzing the time domain parameters as well as system identification.
Okay, basically what this diagram is to give you the overall picture. Chapter, as we have repeated quite a number of times, chapter 1 we went through all the sensors to measure temperature, namely the RTD and thermocouple. To measure the pressure, we have the what we call the pressure gauge, and then of course flow we have the orifice plate, the venturi tube, and the vortex flow meter. And level we have the ultrasound and the capacitive probe, etc. Right? Then of course in the control valve we study about the different kind of control of the valve, whether it's using the hydraulic or pneumatic or the electrical means or electromagnetic means, right? And then of course the body, we also study the body of the valve, the cage, different kind of cage, whether it's a globe valve, is a ball valve, or is a butterfly valve. And we went into studying the CV, how to calculate the CV characteristic computation, and then we talk about the flow characteristic, whether it's a linear characteristic or fast opening or basically many kind, right? Then we talk about the fail-safe device. So that is for chapter 2. Now chapter 3 we went in very quickly, looking at the signal conditioning. That's basically the sample, basically the amplification and the filtering, right? And then we talk about ADC, which we have a few processes. First of all, the sample and hold. The purpose of sample is to reduce the amount of memory requirement, and then of course the hold is to hold it so that you can process it. And then lastly, the quantization, whether you use a half LSB or full VLSB kind of quantization to convert your data into the actual binary equivalence. Then we talk about the DAC, which we look at the lookup table, go and find the actual analog value for the digital equivalent, construct out your step function, and then do a filtering. So that is basically chapter 3. So we finish off chapter 2, chapter 3. Now we are moving into chapter 4. Of course, we will start off chapter 4 by doing the block diagram manipulation. Now, block diagram manipulation is to basically a simplification process, right? So in the actual control plant is usually very complicated. So you need to really simplify the blocks down to maybe one single block so that you can do analysis. And that's basically the main aim of block diagram manipulation. So after this today's lesson on block diagram manipulation, we will go further in to do the first and second order system analysis, and we talk about the steady states response and steady states error for this first and second order. and then we talk about transient response, and of course, lastly is the system identification. So this is what we will be targeting to do in chapter 4. So that's it for the introduction.
There is a distinct difference between an open-loop system and a closed-loop system. In an open-loop system, there is no feedback and the output is not controlled, and they are usually less complex and more susceptible to noise. On the other hand, a closed-loop system uses feedback to control the output. A closed-loop system are usually more complex and less susceptible to noise. Also, a feedback system can result in oscillation if not designed carefully.
So this page is to contrast to you what is the difference between an open loop and closed loop. If you look at the diagram itself, you can see that there is one feedback path added to the open loop to form the closed loop, right? So this is a closed loop and this one is an open loop now. Of course, looking at the diagram itself, we can see that whatever happens, basically the open loop is just whatever you input, you just make an amplification or modification by the system and straight away you go to the output. So whatever happens to the output, you cannot affect the input anymore. It doesn't loop back to manage it. So an example of an open loop system is basically you use a mic to sing in the karaoke. That's an open loop. So you cannot change the volume. If the mic amplification is good, then you have very loud volume. If not, then you have very low volume. So that's as simple as that. Now, on the other hand, a closed loop is basically it's a feedback system. So basically, if your output is not to the desirable level, you want to feedback until it reaches the desirable level. So for example, an aircon system in your house, right? You want to keep the temperature, say, at 25 degrees, and now it's 50 degrees. So first of all, you set the temperature at the input at 25 degrees, and then you will go and drive the system and check what is the output at. For example, right now it's 30 degrees. You say, hey, it's 30 degrees, and you want at 25 degrees, so there is a 5-degree difference. So then the system will work its way towards 30 degrees, and it continues feedback until the error is close to 0. Right? So this is how it works in a closed loop system. And basically for feedback system, sometimes you design it in a stable fashion, it will settle to its final value. But if you are uncareful or not careful with the design, sometimes you may get it to be oscillatory. And as a result, the system will not stabilize at one point, rather it will jump up and down, which is not desirable for a closed loop system. And usually closed loop system, we are talking about negative feedback. Usually positive feedback is to design an oscillator. So this is not designing oscillator, we are trying to design a stable system, therefore it's a negative feedback.
Let's discuss the terminology in a feedback system, since it is a far more superior system compared to open-loop system. In a closed-loop system, there will be the forward and the feedback path. Any block or system that lies along the forward path will contribute to the feed-forward transfer function G(S). On the other hand, any block or system that lies along the feedback path will contribute to the feedback transfer function H(S). The open-loop gain talks about the entire gain experienced by signal when they move along the forward path followed by the reverse path. This is what we call open-loop transfer function G of S, H of S. Finally, the closed-loop transfer function talk about the net effect of G of S and H of S interaction in a feedback system.
If you look at it one by one, very straightforward is forward gain is the one that those blocks that if I move from the input to the output, those blocks that is involved, these are all the forward gain block, right? So if you multiply them all together, that is your forward gain. Now the reverse gain or the feedback gain will be, of course, if I move backward at the feedback path from output back to input, any blocks that is lying here will be your feedback gain or feedback transfer function H of S, right? So the forward gain will be G of S, right? G of S, the other one will be H of S. So the terminology used for forward is G, the terminology used for feedback is H, right? And then of course you have this thing called the open loop gain. Now usually a feedback is a closed loop, right? You feedback at this point. But if I cut this open and then I say that, hey, I want to measure the gain from here and then loop back to this point before it closed the loop, right? So in order to know the entire loop gain, I got to open this loop and then say that, hey, I only allow it to go by one time, forward and reverse. So the total multiple of the gain at the forward path and the feedback path will be your loop gain. That is G of S times by H of S, right? Now, in the closed loop transfer function, basically, I let the closed loop take over, right? So therefore, I connect the feedback and I let it run. So the net effect of this red dotted line, meaning that it loop and keep looping, this is your what we call the closed loop transfer function, which is given by G of S over 1 plus G of S H of S. Now this one, you will learn it in the later part of Rule 7 and Rule 8, which specify why this is so. So for now, you just take it as G of S over 1 plus G of S H of S.
Rule 1 for block diagram manipulation. Moving a summing node in front of a gain block G. In order to get back the same expression for output X3, we need to insert an additional gain block G for input X2.
To look at, of course, we have 8 rules. Now, the first rule is to say that, hey, if I have originally a gain block and a summing point here, and I want to move the summing point ahead of this gain block, now what do I do? Now, of course, everything you look at it as a black box. There is 3 input. And of course, when you move, you don't want to intervene any of the input. Meaning that input may be still okay, you still input X1, X2, but output, you should remain the same, right? So for this case, for example, this case, the originally is 1 plus minus X2 here, right? At this point, if you look at it, X1 plus minus X2 will come out at this point, right? Now, X1 plus minus X2 go into the G, that means the whole thing, the G will multiply by X1 plus minus X2 will give you X3. So X3 is basically this expression here, right? X3. So if I move the gain over here, I need to add additional block here. Now, if without additional block, then it will not be the same expression anymore, right? For example, if without the block, what will be X3? X3 will be X1 times by G plus by X plus minus X2, which is not the case because there is 1G shortfall of 1G. So what happens is you need to inject a G here. So therefore your G will come here. So when you take out the common factor is X1 plus minus X2, which is the same case as the top. Okay, so that's how it works. So you need to replace, that means you need to do some modification to the block. If you want to shift it here, you can do a modification so that whatever input, it will come out, still get the same output. Same, both of them is the same, right? Still get the same output. So therefore, even though you do the modification, it's still equivalent in a sense that the black box equivalence case, right? Now that's for rule 1. Of course, rule 2.
Rule 2 for block diagram manipulation. Moving a summing node to the back of a gain block G. In order to get back the same expression for output X3, we need to insert an additional gain block 1 over G for input X2.
So similarly for this case, X3 is given by X1 times by G, which is here, right? Plus minus X2. So X1, G plus minus X2. So this is X3. Now, if you move this point to here without putting this block, then you would have X1 plus minus X3, sorry, plus minus X2, then times by G. So which is X1 plus minus X2 times by G, you have extra G here, extra G at the X2 there, right? So then in order not to have this extra G, you got to, for the X2, you got to divide by G first. So you have a 1 over G here. And then when you multiply totally by the G, you will cancel each other. So X2 is itself finally still don't have extra G, but X1 have a G, right? X1 have a G. So this expression, after inserting this 1 over G, basically result in the same expression. So we can term this, if let's say this is a black box and this is a black box, they are exactly identical because there's no difference after inserting 1 over G. That means if you move backward here, you got to insert 1 over G. Okay?
Rule 3 for block diagram manipulation. Swapping summing points. There is no amendment to the diagram when swapping summing points. For the before and after swapping, output X4 remains the same.
So for summing point, which is rule 3, it is always the same. You can just swap as you like. There's no modification or no additional or blocks to whatsoever. So therefore, for example, this case, you have X1 going in, X2, X3 coming in. and then if you look at the expression is here, this point here will be x1 minus by x2. Then you x1 minus by x2, you go in, you plus by x3, so it's basically x1 minus by x2 plus by x3. So this is your net result for x4. Now, if you swap the two summing point, then basically you have x3 coming first, followed by x2, right? So we go through the same analysis again. The output at this point will be x1 plus x3, right? Then after x1 plus x3 go into here and minus with x2, so x4 will be again the same thing, x1 plus x3 minus x2. So you look at it, you rearrange it, is actually basically the same. So there is really no difference when you swap two summing point together. Right? So summing point you can just swap at any time you like, but you do note that it is called the rule 3, right?
Rule 4 for block diagram manipulation. Moving a pickup point to the back of the gain block G. In order to get back the same output expression for x2b, we need to insert an additional gain block G for x2b. Output x2a, no change as expression remains the same.
Now, again, this is moving, just now we are moving summing point, right? But now we are moving the pickup point, right? Pickup point basically originally is like that. X2a will be x1 times g, x1 times g, right? Now, then x1 will be also x1 times g because it's just equals to x2a, right? So basically, this is the original situation and original output. Now, if you move this guy without adding a g, then you would have 1 g lesser. That means x1 will go to x2a. So basically, there's no g here. So therefore, because of that, you got to add another g so that to come out a same expression for x2a. But for x2b, or not x2a, but x2a will be still the same because it's x1 times by g to give you x2a. So there's no difference for x2a. But x2b, if let's say you put here, there's no g here originally. But of course, you got to insert a g, then you get back the same expression. So that's basically what it means, moving a pickup point to the back. Okay, once you move to the back, you got to insert a g to really make sure that the output maintain the same, right? So then
Rule 5 for block diagram manipulation. Moving a pickup point in front of a gain block G. In order to get back the same output expression for x1b, we need to insert an additional gain block 1 over G for output x1b. Output x2, no change as expression remains the same.
For this case, just now we move back, right? Now we move forward. The same thing, the pickup point. Now, of course, we always like to observe the output. So the output x2 will be equals to x1a times by g. So x1a times by g. Now, how about x1b? x1b is actually x1a, so there's no change. Now, if you move this guy ahead here, then what happens? x2 remain the same because x2 will still be x1a multiplied by g will remain the same, but x1b will be slightly different because x1b you experience a gain here. So if you don't multiply by the 1 over g, you have extra gain, right? So that's why the 1 over g is inserted, and then if you insert this 1 over g, you cancel out each other. So therefore, it's still maintained as x1 over a. So that's the reason why we insert 1 over g here, right? So that's rule 5, total of 8 rules, which this one you have to remember because the rule, we don't put it inside the formula sheet.
Rule 6 for block diagram manipulation. When summing point is in front of two blocks, just add or subtract depending on the sign at summing point.
Now this is summing point of in front of the nodes. So do remember that this is, both of them are forward. None of them is backward path. These are forward path and these are forward path because both of them are G. Right? Both of them are G, both of them are forward path. So therefore, if you look at it, x1 times G1 here, x1 times G2 here. And both of them add together, you will get x1 equals to x2 equals to x1 bracket G1 plus G2. Right? Now, if you, instead of writing this, because they are plus together, so you just put the expression G1 plus G2, and then you multiply x1, you multiply by this G1 plus G2 gain, you get x2, right? So you look at this, and that is actually the same thing. So for forward summing node, it is this way. That means the summing node in front, ahead of these two blocks, it is this way. Now, For rule 7, rule 8, it deals with feedback. This one is both forward, feed forward, no feedback, right?
Rule 7. For block diagram manipulation. When summing point is at the back of two blocks, use the formula G/1 plus GH for negative feedback.
So basically, if you just remember, then it is very straightforward. Basically, if you have a forward path and you have a feedback path and the feedback is negative, then what happens is if you commit to the memory, in fact, I have committed to a memory, then the closed loop transfer function, or rather they always call it the closed loop transfer function, will be G/1 plus GH, right? G1H. Why is it so? The derivation here will teach you what you mean by this, right? So, but nonetheless, it is really saying that you know, you have a negative feedback path. If you minus here, here must be a plus. Now, let me try to basically solve this for you by explaining to you this, or maybe I should use this to just to explain to you. Now, X is basically what? X is actually the error, right? The error here. Now, X is basically U minus by Y of Y times by H1. So this is equation 1. Y times by H1 is presented here. X will be U minus by H1Y, right? So equation 1 you form. Now, equation 2 is Y is actually X multiplied by G1. So this is, if you error go inside the gain function, you will get Y. So these two. Now, if you substitute equation 2 to equation 1, that means this equation to the 1, right? So then you will have what? You would have, of course, how do you substitute? You basically eliminate the X away. So that basically, if X is Y over G1, so you just put Y over G1 and you bring your G1 over. So basically now you have Y and Y, right? Y and G1. So this is after substituting. Then what happens is if you want to know something over U, then if you rewrite this guy, you would have how do you get that? You have bracket G1 here, 1 minus H1Y. So basically from this step, it never explained why it comes to this step. Maybe it's better for me to just derive for you, because it doesn't seem to show you the full derivation. Let me share it with you, so that you will be clear how you get there. But eventually, when you do it, you just no need to memorize it. So let's say I start off with my G, which is the forward gain, and H, right, is the feedback gain. And then of course you have your output feedback to here, and then the input, of course the summing point, right, and then the input, right? Now if this is your I use the same one. If this is your U of S, and if this is your Y of S, and this is your X of S, right? So setting up the two equations is very straightforward. First of all, your Y of S is equals to X of S multiplied by G. This is X of S times G, you get Y of S. Very straightforward. And also you have X of S equals to U of S minus by Y of S times by H, right? Because Y of S times H will be presented over here. And this is a minus sign, this is a plus sign. So that's the reason why you have a minus here, right? So far so good, huh? Now, with these two equations, how do I manipulate so that I can get, I actually don't want the X, because X is already here. So what I can do is I just, okay, if I call this equation 1 and equation 2, right? Now, if I substitute 2 into 1, so that means what I get here is Y of S will be equals to X, right? X is U. u of s minus by y s h of s, right? This is u, right? This is h of s, right? Multiply by g. G is g of s, right? So this is your y, right? Right. So if I multiply in, then I basically have u of s, g of s minus by y of s, g of s, h of s. Right. If I bring the y over to this side, basically I have y of s plus by y of s, g of s, h of s. Right. And then is equals to u of s, g of s, g of s. Right. So if you common out the term, you take the common factor y of s, then what you have is 1 plus g of s, h of s, right? That is this side. And then, of course, here you have u of s multiplied by g of s. So there's no this term. This line here will be rejected. Okay, then now you really need to find what is y of s over u of s, right? So y of s over u of s is actually, you can bring your u over here. So it becomes y of s over u of s. And then this guy you can bring over to this side is actually g of s over 1 plus g of s, h of s. So that is basically it. So like I say, for minus feedback, you get plus gain. Yeah. So this is rule 7 for you. Rule 7. Can? Which is exactly what we have, which is exactly what we have did here. Okay, rule 7. So simple as that. Now rule 8 is basically changing the sign. So if you change this sign to plus, then this become minus.
Rule 8.
Right?
For block diagram manipulation, when summing point is at the back of two blocks, use the formula G over 1 minus GH for positive feedback.
So basically, it's nothing new. If you go through the derivation, it will be the same derivation as what I did just now in the whiteboard. So it's going to be the same thing. So I'm not going to repeat this derivation again, right?
Please watch the tutorial 7.
So for tutorial 3, we'll be discussing question 1 and question 7. We'll go with question 1 first. Then we will try to solve for block diagram manipulation for question 7. Now let me start to go to the tutorial question. Let me see more windows. Where's my tutorial question? Now tutorial question is here. Now question 1, it asks you to, the first question that we need to do is draw and label a closed loop system with negative feedback. So this one is very straightforward. I already have the solution prepared. Right, the solution prepared is where? The solution prepared is here. Right, so basically it's this block. This is your block diagram of closed loop feedback. So you basically have control element, you got the plant, and you got the controller basically, and then of course you got your measurement and feedback element here. Right? So this is your forward gain and reverse gain. So this is basically your block diagram manipulation that they asked for, right? So straightforward, you just copy from the textbook you will know. Now, then the other question will be question 7, right? Question 7. Now look at question 7, you have part 1, part 2, and part 3. Basically, part 3 is the most complicated. Part 1 and part 2, it's more straightforward, right? So they ask you to write down the overall transfer function for the following. So basically, it's ask you to simplify and get only one block. The first one is easy, right? First one is easy. So let's try to solve part by part, and then later we will say, see how it's being done. Okay, so for this guy here, I would clear all. Now I will do 7 part 1. Now 7 part 1, question 7 part 1. Let me put it to drawing first. Now question 7. For question 7, part 1, okay. Question 7, part 1, it has a, let me see, it has a forward transfer function of 2 over s plus 1, right? And it has a reverse feedback transfer function of 5s. So basically, it is a forward block and a reverse block. Reverse block, and then you have output feedback to here. Of course, there's a summing point here, and then you feedback to here. Okay, and then of course the input here. Now input here is u of s, and output there is y of s. Now it asks you what is the overall transfer function, right? Overall transfer function is actually the closed loop transfer function. Now this, you simply just use rule, because this is a negative feedback, right? Negative feedback, you just simply use rule 7. So you use rule 7. Rule 7 states that if y of s over u of s is actually equals to g, which is a forward transfer function, and it's basically g of s, we just derive it, right? Plus by 1 plus by, because it's negative feedback, then this is a plus, g of s, h of s. H of s. What is your g of s? Your g of s is basically 2 over s plus 1. Now what is your h of s? H of s is not 1, now it's actually 5s. Right, 5s. So with this, you just plug in the top g as 2 over s plus 1 divided by 1 plus 2 over s plus 1 multiplied by 5s. Right, so what you get is 2 over s plus 1 over 1, you can convert to s plus 1 plus s plus 1. So it's s plus 1 over s plus 1. That's 1. And then plus by 2 times 5 to be 10. Plus by 10s over s plus 1. So right now you can see that all of them are common factor of s plus 1 here over s plus 1 plus 10s, right? S plus 1 plus 10s over s plus 1. S plus 1 can cancel each other. So basically you are left with 2 over s plus 11. Understand what I mean? So, sorry, is 11s or, sorry, it should be 11s plus plus 1, not the other way. Because 10s plus s, 10s plus s is 11s plus by 1. Also, this is basically a first order system after simplification. That is for part 1. Okay. Now let's look at part 2. Part 2 of your question for question 7. Part 2 is slightly more difficult, but of course it's still manageable. Let's go back to the whiteboard. Of course, I clean it first, clear all. I hope you roughly get it. So right now, let's draw the diagram for 3 summing points. So you have 3 summing points here. 1 summing point, 2 summing point, then you have a block, right? Then another summing point. Then you got 2 blocks, right? And then you got a block below here. And you got a block on top there. So the line goes this way, this way, this way. Then it goes this way, this way, this way. So basically there is a forward. Then of course there is a feedback. Feedback is from here back to here, right? And then of course it goes to one of this point here. And it is a positive feedback. So this guy is a, if I cross this guy is a positive feedback. Right? It's a positive feedback. And then of course the other guy is fed back to what? Feedback to the first plant. So this is feedback to here. Of course I have a cross here. And this guy is again is a negative feedback. Right? Of course this guy draw from where? Draw from the output C. Right? This is C. You draw from C. Right? Then there is another feedback which we haven't drawn, which is from output all the way to the input. So from output here all the way to the input. Sorry. Let me clean this up first. It's from here to join to there. Okay. So basically, we have all the blocks, but we haven't filled in which block are for what. So it's basically G1, G2, G3, right? So this is G1, this is G2, this is G3. And the other one is H1 and H2. H1 below and H2 on top. Now, you see, you look at this guy here, you have many feedback loops, right? Many feedback loops. Of course, this guy is again the net minus feedback here. And this is a plus, then you are R. So the question is, they ask you how to solve for, how to solve for the, how you simplify it basically, right? Now, first step, what would you do if you are in this situation? There is this loop here that entangles with this loop because there's a common path here. One path is shared by two. And then this guy here also have a common path with this. So it's very messy. So my first step I suggest would be to move away this picking point. Right? If I were to move this picking point to the front, so what happens to the whole transfer function? So if I were to delete this, and I say I change the color, for example, I change the color to red. Now I move my moving point to the front. Now is that going to be the same? Because just now I tapped from here. So signal come into here, come out to H1. But now there's additional, it go to G3, then come down. So therefore I cannot just straight away insert like that. I have to insert 1 over G3, right? Am I correct to say that? Because it went into, originally it come down from here. Now it went to pass into G3, it means you have additional gain on G3. So it coming back, you must divide by 1 over G3. Right? So if you put here, so it makes sense, right? So it makes sense. Now, this when I move it into this kind of fashion, now G1 and G2 can multiply together, right? Because they are just one block by itself, right? So basically, I can change G1, G2. Right? G1, G2 now can change to one single block. So it's G2, G3 now, G1, G2. So now I change the color again. Now G2, G3, I can merge to be one block, right? G2, G3. So this is your new block, right? Connect to here, G2, G3. Now, of course, this guy also I can change into one block, right? H1 over G3. So I can delete this guy as well, H1 over G3. Let me put it back. And of course, I put back this same as H1 over G3. And this is the line that goes to here. And of course, there's another line that goes to here, right? Which we accidentally deleted. all the way to here. Right. Now with this, what can we do now? With this, remember you see here, this is a forward path and a feedback path. This is a negative sign. So basically what we have here is, this is, you can apply what we call rule 7, right? Rule 7, you can basically eliminate this to become what? Rule 7 is G over 1 plus GH, right? So it's G2, G3, that's your G, over 1, because this is a minus feedback here. So it's a plus, then it's a G again, G2, G3, multiplied by H2, right? H2. So this is your equivalent. So now with that, I can rub away this guy here. I can rub away this guy here. Let me use this thing to control it. It's easier. I can rub away this guy here, right? Because now I already simplify it to basically G2, G3, right? So then I rewrite this this expression over to here. So it's basically G2, G3 over 1 plus G2, G3, H2. So this is a new equivalent here, which you connect to here and connect to here. Now, of course, this term also can merge with this, right, by multiplying in. So therefore, I can also delete this guy and add the G1 into the numerator, right? So now I can add the G1 here. Can you see? So it's very beautiful. I have actually simplified a lot of the blocks suddenly, yeah? Right, a lot of blocks suddenly. Now you see, look at this. Again, is a feedback, but this time around it's a positive feedback. Now we can use rule 8, positive feedback, right? So positive feedback for rule 8, how do? You take the G, which is G1, G2, G3, there's a G, over 1 plus G2, G2, G3, H3, H2, right? This is your G over 1 minus, right? Because this is a plus here. Minus G1, G2, G3 over 1 plus G2, G3, H2, right? You multiply by your feedback, which is GH, H1, G3. Now you notice that there is G3, G3, you cancel them, right? You can cancel them. So then your new expression will be, of course, this guy here is no good because you can't convert with the different denominator. So let's change this guy, right? Change this guy to the same denominator as the top and bottom. So I change this guy to what? 1 plus G1, G2, G3, H2 over 1 plus G2, G3, H2. So this, now all the three terms are having the same denominator, right? So now how do I do? What do I do? So since all of them are having the same denominator, you can just cancel all their denominator away. All of them having the same denominator. Then the net result is you would copy all the numerator here. So the numerator for the top will be G1, G2, G3, right? So that is your top here. Then, of course, the bottom is 1 plus G2, G3, H2, right? 1 plus G2, G3, H2, and then minus by G1, G2, H1. Right? So this is your after simplification, right? So basically, I can replace this entire block by this simplified answer, right? So basically, this block will be replaced again, right? Will be replaced, and I write the equation over here, right? So it's basically G1, G2, G3 over 1 plus G2, G3, H2 minus by G1, G2, H1. Oh, so basically it's not over yet. You still got one more line, right? If you look at it carefully, there is still one more feedback line. One more feedback line. So of course this part here you can eliminate already because no use. Let's see if I can clean it faster. So calculation wise, of course, all this calculation, if you're in your test or exam, you have to leave it there. I don't delete it. So then you have your G and your feedback. This guy H is actually equals to what? This guy H here is actually equals to what? H of S is actually equals to 1. Oh, with unity feedback is just equals to 1. So basically you can rewrite here again, G1, G2, G3 over 1. Over 1 plus G2, G3, H2 minus by G1, G2, H1 over itself, over 1. This is 1 plus because your feedback is minus, right? So it's 1 plus. Then of course multiply by this guy here, the same term again, G1, G2, G3 over 1 plus G2, G3, H2 minus by G1, G2, H1. Again, your main problem is to do the conversion, right? Conversion of this number 1 here, right? Number 1 will be, of course, you put to the same denominator is 1 plus G2, G3, H2, right? G2, G3, H2 minus by G1, G2, H1 over itself, over 1 plus G2, G3, 3, H2 minus by G1, G2, H1. So now all your denominator is the same. So again, we do the cancellation. So we cancel the denominator, and cancel the denominator, right? So right now you write all the numerator. So right now, if all the numerator, the top numerator will be, I just write below here because upstairs there's no space. So you have G1, G2, G3, top one, right? Of course, bottom will be 1 plus G2, G3, H2, right? Minus by G1, G2, H1, right? And then of course plus by G1, G2, and G3. So this is your final result, right? So your final result after you eliminate this, you can write into your black box, right? You can write into this black box here. Let me change it to drawing. Now you can write into your blackboard here. Sorry, here maybe, yeah. So you can write here as G1, G2, G3 over 1 plus G2, G3, H2 minus by G1, G2, H1 plus by G1, G2, G3. G1, G2, and G3. Right, so this is your final expression, final block. Right? Oh, so this is your final block. Right? So working, I can drop away, just not to confuse the page. Now, it started off by asking us what is your C of S over R of S, right? What is your net result after simplification. After simplification, you just get one block type. So basically, in the answer, you can write down C of S over R of S is equals to this expression. So it's equals to G1, G2, G3 over 1 plus G2, G3, H2 plus minus by G1, G2, H1 plus by G1, G2, G3. So this is for part 2, 7 part 2. Question 7, part 2. Now let's check the answer, whether do we get the same. Yeah, pretty much the same, right? So this is pretty much the same after solving for quite a while. Oh, so that's how you solve for question 7 part 2. Now, of course, the part 3 will be slightly more complicated, but I will also still go through with you, right? So maybe I just go to the previous screen and let you stay for a while before I clear it. Of course, you can always rewind and watch it again. Right? So right now, let's go to do the part 3. Of course, for part 3, I have to still draw the diagram. G1, G2, G3. Let me look at it first. So, okay, where am I sharing? Okay, I'm in the blackboard. I'm at the blackboard. So basically, I need to draw G1, G2, G3, G4. Right? Of course, in between G1, G2, there's a cross. There's a summing point. G1 cross. Then I have G2 cross. Then I have G3, G4. Right? Then of course I have H1 below. So basically I can box it up. Then I have this summing point going to where? This summing point coming from G3, G4, right? So G3, G4 go up, there it goes to one block. Goes to one block and come back to the summing point. Right? And that is actually H2. Then the other summing point is coming from output H1 to the mid summing point here. Then you have a H1. It's coming from the output here. Output goes to there, right? Now the other one, the other feedback path will be H3, going all the way to the front summing point. There's another summing point here. Then H3, which is basically from output here. From output here, it goes all the way to there. And of course, your input. Right? Your input is R and output is C. R of S and C of S. Yeah. Now let me put on a different color to denote all the sign. Yeah? So the first one is minus here. Then the second one is plus and minus there. So there's a plus here. There's a minus here. Okay, to solve this question, first of all, you again got to unentangle the loop. So you got one loop here, which is overlap with the loop here. There's a common path here. And then again, this loop is also overlapping with this loop and this loop. So how would you solve this guy? Now for me, my first intuition, if I look at this question, I would basically move this point, this pickup point from here to the front, right? So if I try to do that, basically I will erase this guy here. And when I do that, I would basically, okay, I cannot just put here, right? Because I incur, originally it comes out and go up. It only go through G3, it never go through G4. But now you go through additional G4, then on top here, you must add another 1 over G4, right? 1 over G4 in order to move it to the back, right? So this is how you move it to the back. Okay, now since you break this path, since you change this tapping point, now these two can combine, become H2 over G4. So I can change this, right? H2 over G4. And write it as H2 divided by G4. And also this guy, I also can change because it's G3 times by G4, right? So then I can change this guy as G3 times by G4. Just by one move, you can see that a lot of G3 times by G4. Right? So you can have so many things change. Now you look at this, there is a rule 8 here, right? Rule 8, G over 1 minus GH. So what is G over 1 minus GH? G will be G3, G4 over 1, because this is plus, then we give a minus here, minus G3, G4. H, this is H1, H1 or H2? H1, so H1. So that will be a simplified expression for this guy here. So with that, I can rub away this portion here. I can rub away this portion here, right? And then insert the new expression over here. So the new expression will be G3, G4 divided by 1 minus G3, G4, H1. Right? Of course, just now that one, this was accidentally dropped. So basically, you have really changed the whole thing. Right? So of course, let me erase away this guy here because I don't want it to be messy. Now this thing also can combine inside. That means you multiply G2 into here. So basically also you can erase this G2 away, right? So I combine it into it. So basically you got G2 over here and you have it coming into here. So again, this is a forward and this is a feedback and it's a negative feedback. So you can have rule 7 this time around with your G and H as this. So you're okay, then we do a rewriting of G and G over 1 plus GH, right? So G is G2, G3, G4, right? Over 1 minus G3, G4, H1. Okay, that's your G divided by 1. This is minus, therefore is plus. G2, G3, G4 over 1 minus G3, G4, H1. Okay, now you cannot ignore the H, because your H of S is, you got to multiply your H of S. H of S is H2 over G4. Right? See here, it says G4 is the same, you cancel, because multiplication, you can cancel. So right now, you got to change this, change this guy here. Let me change the color. Change this guy to what? Change this guy to the same denominator, right? Same denominator, it be 1 over 1 minus 3 G3, G4, H1 over 1 minus, again is why cannot 1 minus G3, G4, H1. So this is itself divided by itself, so it's equals to 1. So with this, now we have all the denominator is the same, so you can cancel all the denominator, right? And write out all the equivalent new numerator, right? So what is your numerator for the top? The numerator for the top is G2, G3, G4. That's the numerator for the top. Now bottom will be, you just need to copy this 1 minus G3, G4, H1. 1 minus G3, G4, H1, right? And then plus by this multiplied by there. Plus by G2, G3, H2. So that is your new expression for this whole block, right? So now we can erase away that block. Basically, we can erase away this one, right? Because we just simplified, right? So including the summing point. So we have basically here as G2, G3, G4, right? Over 1 minus G3, G4, H1 plus by G2, G3, H2. So this is a very big term, right? But again, this guy can be multiplied in, so I can also eliminate this guy, right? So then I would have G1 over here, and I have a new block with a unit feedback. So this H of S is actually equals to 1 for unit feedback, right? Now if I erase away the working, so what is this new G? This is rule 7 again. Rule 7. So you have to write your G, G1, G2, G3, G4. There's your G over 1 minus G3, G4, H1 plus by G2, G3, H2. That's your G over 1 plus, right? Your G again. There's no H, H is equal to 1, so it's 1 plus G. So G is G1, G2, G3, G4, right? Over 1 minus G3, G4, H1 plus by G2, G3, H2. Okay, so now the next thing is you got to deal with your 1, right? This particular 1. So you got to convert it into the same denominator. It will be 1 over 1 minus by G3, G4, H1 plus by G2, G3, H2 over 1 minus G2, G3, G4, H1 plus by G2, G3, H2. So that the top and bottom is the same and become 1. So right now we can do the cancellation of the denominator, cancel, because they are all having the same denominator. And now we rewrite the numerator. So the numerator will be G1, G2, G3, G4 on top, right? Below, what is the value? Below you have 1 minus G3, G4, H1, G3, G4, H1 plus by G2, G3, H1, right? H2. G2, G3, H2, and then plus by, this is continuing the denominator, G1, G2, G3, G4. G1, I write the below, G1, G2, G3, G4. Oh, this is continuation of the denominator. Okay. Oh, basically is this plus minus by this, plus by this, and plus by on top. Okay, plus by on top. So basically after doing that, you have finalized the whole block, right? So basically what you can do is write the expression over here as G1, G2, G3, G4 over 1 minus by G3, G4, H1, H1 plus by G2, G3, H2 plus by G1, G2, G3, G4. And that is your final expression. Let's take a peep to see whether what we obtain here, is it the same as the result that was given, right? So we take a peep here. Now it looks almost the same, right? There's another H3. Did we miss any H3? So that's why sometimes you got to be very careful. But anyway, the method that they use is exactly the same as what we have shown. So that's how you simplify and get to the final one. But because this is writing online, so sometimes I might miss out certain things because the pen is not that smooth. If I'm doing it in a pen and paper, that would be better. But this is to show you the steps of how the simplification can be done. Now with that, I finished the entire block diagram manipulation and also the end of this week lesson. I thank you for your patience. I'll see you the next lesson.